Hey everyone, Adam Savage here. To film the miniature of the Onyx Cinder for Star Wars Skeleton Crew, ILM's John Knoll built a motion control camera rig using today's latest technology, but following the design cues of the original Dykstraflex camera rig that filmed the first Star Wars movies. We visited Lucasfilm during the filming of the model to talk to John and to watch and learn how the legacy of motion control still lives on at ILM and in a galaxy far, far away.
John, I'm so glad we get to talk about this on camera. You and I have been texting about this for years. But this is your garage-built, fully functional motion control system.
Homebrew motion control system, yeah.
Walk me through.
Well,
I love these decade counters, man.
Yeah, so this is essentially a Arduino project that's just gotten out of control. There's a Teensy 4.1, which is like an Arduino. It's faster processor with more memory in it. And all of the motion control is actually running on that little microcontroller. Wow. And the computer here is actually just a serial terminal talking to it. So the move, all the move editing commands, all the shooting commands, they all just execute on the microcontroller.
And you have used almost every motion control system ever built up until this, yeah?
Yeah, I mean, that's how I started. I was a model maker and then a motion control camera operator, and I got hired at ILM in the camera department. And then I operated motion control for a number of years here. And I actually spent some time building motion control equipment back during that time. And then I moved into computer graphics and effects supervision. So I was away from it for a while. And when this popped up, I was ILM side soup on Mandalorian when this whole idea of building a miniature and shooting it came up. And
now, how did Favreau just really want a practical shot in Mandalorian, or did you let him know that the art of the possible might be more than he considered?
Well, it came up when we had built this actually very nice CG model of the Razor Crest, and we were doing our first renders of it just in a space flyby, and he was questioning, would the glints be brighter than that? Something doesn't feel right to him. Yeah. Shouldn't we build a study model and shoot some stills of it to know for sure what our target should be on this? Yeah. And so we began building this miniature, and then Landis Fields actually started advocating for, hey, if we're going to build the model, we should shoot some elements of it and put it in the show. And that got us thinking about, all right, well, what would we need to shoot a miniature? And we need some track and a motion control system to really do it properly. Because part of this is an exercise of old school nostalgia.
Yeah, totally.
So let's do it old school style.
Old school style, except that the BattleBots and robotics revolution in the past 20 years, the maker movement with 3D printing and Arduino has made it possible at a fraction of the cost, size, and weight.
Yeah, so back in college, I spent a bunch of time learning basic digital and analog electronics, and I fell out of it for quite a while and got back into it around 2009, 2010. And oh my God, two things. The internet has made hobby electronics super fun and really cool.
Awesome.
And the whole Arduino ecosystem has been great for all of that. Because almost any sensor, any hardware device you could ever want, if you do a Google search for that device and Arduino, somebody has already
figured out a way to get them to talk?
Yeah, has already figured out how to drive it and posted some code examples. So you can really talk to just about anything. And that sort of led to all of this.
And to be totally clear, you hand-built all this.
Yeah, this is all... the three legs of engineering are mechanical engineering, electrical engineering, and software engineering, and that's all present here.
You're doing all of that.
So yeah, I machined a lot of the custom pieces here. Anything that I couldn't purchase off the shelf, like the pan tilt head and the model mover, are all custom machined.
Okay, so this machine talks to all of the elements that create the shot: the camera, the mover, the ship, its movement, and lights.
So yeah, what's specifically going on here is there's a tiny little microcontroller in here that generates the pulse trains. The pulse trains go here to the drivers. So these are stepper motor drivers in here.
Okay, they move. They make the actual motors turn.
Yeah, they energize the coils and the stepper motors and get them to turn around.
And then they turn in really specific increments for you that are super repeatable.
Exactly. So you can be very precise about the position and speed at any one time.
Can we move some stuff and watch it go?
So the other part of the motion control system is you kind of need a remote unit.
Because I've seen remote units like this since the beginning of my time in the film industry.
Exactly. So this is my version of the jog box that we used to use, because there's a lot of things you kind of have to be looking through the viewfinder, or you have to be over at the model adjusting.
Right.
So
in terms of literally adjusting for the shot and knowing how the move's going to go.
Exactly. And sometimes it's even just clearance issues.
Right. You don't want to hit the model.
Very, very often we are just missing the model by 1/4 of an inch, and you want to.
And that's important for scale too, right?
And all of these devices have the big red button on them,
which stops them immediately.
Yeah, that's the emergency stop. So if ever you're seeing that, oh no, something bad is about to happen, I can always stop it by just hitting the button. So I want to have a button that's just right under my thumb, even when I'm pretty far away from the console. So let's run the camera down here.
It must be nice not having to rewind the film for in-camera passes.
Yeah. I'll say that all of this is a lot easier using digital cameras. Yeah. And a couple of people have expressed some surprise that I'm just using a still camera, but essentially with motion control, you are just shooting a whole series of still photographs. When we're shooting, I'm shooting generally 1 second exposures, so the whole thing is moving a bit slow. And these cameras are really good still cameras. They're somewhat higher resolution than our motion picture cameras.
Wow.
Like the frames that I'm getting are 6,700 pixels across. So plenty of resolution. They have good dynamic range, good colorimetry, and we use them all the time for a lot of effects purposes.
Now, I think what most people don't realize is that when you're doing passes for the ship and the ship is flying by the camera, you're doing this multiple times for different elements. Is that right?
Yeah, exactly. To give the compositors more control over the pieces that they get, generally I shoot key, fill, running lights, cockpit lights, engine lights, and blue screen. Shoot those all as separate image streams, so then we can rebalance them.
And you can bring them all in.
Yeah, so if the fill light needs to be a little bit darker and a little bit more blue, because we've shot it separately, we could just do that very easily in the composite.
Now, with this long track, what is this, like 60 feet?
It's 50.
50 feet.
Yeah.
How is your repeatability when you're matting these against each other?
It's pretty good. Before I move on, when we shoot an element, before we strike it and move on to the next, I get all the frames onto the computer here and I do a registration test.
Sure.
So I lay them all over each other and just check that everything repeated properly.
That there's nothing really sticking out.
Yeah.
I would imagine small differences can be massaged in.
Yeah, as long as it's not too bad, you can stabilize them to each other in the composite.
All right, yeah, so sorry, continue on.
All right, so then...
I love how small this is. It's hilarious considering.
Yeah, that's been part of the fun of this is, it used to be the cameras were much bigger and heavier. Yeah. And I delight in that these digital still cameras are much smaller, and then I can build a pan tilt head that's basically just big enough to hold one of these cameras.
You custom built all this in your shop?
Yes. Yeah, this is, and you see that this one hasn't been anodized, and I haven't built a cover for it because I built this like the week before the shoot.
So fresh off the press.
The new head was a stretch goal. Yeah. Like I had my whole list of items that had to be completed. Like this is a new version of the pitch mechanism that was re-engineered to hold these heavier models.
Gotcha.
So that was a must-have. Like we can't shoot if I don't have that.
Right.
So I had a whole list of must-haves that I had to get through for us to be able to do the shoot. And after I finished working through that list, then, I've got another week and a half left. I'm going to build the new head. And so I rushed through building the new head. It's together, it works. when the shoot is done, I'm going to take it apart, I'm going to get it anodized, and I'm going to make a cover for all the exposed mechanics on it.
Oh, fantastic.
And
Sorry,
then
I keep interrupting you while you're moving.
yeah, it's, also there's a tilt and a focus on it that are pretty self-explanatory. The model mover is a 3-axis mover as well, so it has a yaw mechanism.
Wow.
And
just seeing it move is actually quite thrilling.
and then we have so right now this is kind of acting as a pitch. Most of the time we're doing a side mount, so this is actually the roll.
Ah, okay, gotcha.
Okay, and then I have what is right now a roll mechanism, but is usually used as a pitch.
So all of this is, you're reconfiguring all of these controls for every single shot.
We remount the model as necessary. Right. So just like the back in the day, these models are engineered with an armature inside and multiple mount points. So it actually can mount from the 6 directions.
Right.
So right now we're on a back mount, but there's a top, a bottom, left, right, and a front mount as well. And so what we're trying to do is use the mount that is going to be the least visible to camera.
Right.
So the shot that we're about to do here is one where we're really just looking at the front of the ship. So this is a good one for a back mount.
Sure. And I was talking to John and Dan, these motors all move. That's part of the narrative as well.
So, yeah, they all pivot. So as you can see.
Oh, I just love watching that.
Yeah, there's 4 axes built into it. And the back ones move as well.
Oh, okay. I was wondering if those move separately than the wing, but they move on. The wing itself moves.
Yeah. So there's independent animation on them, and as the kids are flying around, we've worked out the language that we're using for how they move. If you want to roll the ship, then you tip one side up and the other side down, and it rolls the ship over. Or if you're trying to come in for a landing, we'll steer them to be sort of a vertical takeoff kind of.
So you get a storyboard of what the ship's movement is supposed to be through the frame.
Yeah.
And does the lightweight and easy configurability of this make it easy for you to shoot like a couple of different tests of what that might look like and really improvise?
Well, what we're trying to do is really economize our time on stage here. So what we try to do is figure out the shots and get them all designed and approved beforehand.
Okay.
So we've got a version of the motion control system that is in the computer that we've rigged up so that we can design shots that are within the performance envelope of the system, so that we're not designing things that where the camera would intersect the model or we go beyond the limits of the travel.
Is that including even things like how the lighting is going to fall on it, so you have an idea about how to set up the lights once you're on stage?
To some extent, yeah. Having the system visible inside of Maya does tend to constrain the animators from designing shots that can't be executed because of things like, there's no way to mount it. Right. If you can imagine a move where there's no way to mount it because if you're going all sides, at some point the model mover is going to occlude some part of the model. And so this puts some limits on that.
Right. The big white box behind this.
Yes.
Does that light up?
It does. There's a rotation mechanism inside of it, but it's covered with this milk plexiglass, and inside are blue LEDs.
So is this just the equivalent of those fluorescent bulbs that held up the Millennium Falcon way back in the day?
Yeah, it's exactly the same idea. When we're shooting our matte pass for this, we set up a blue screen behind it and light it up. But you can imagine that if the camera's over on this side, you don't want a big mechanical model mover, the support for all of this, to then not be blue, and then, all right, that's something we've got to roto.
Yeah.
So this light up pylon gives you a continuous blue screen even where the support is.
Amazing.
That's the idea.
With all of this advance, is there anything about this process that is still just like, wow, that is still a pain in the ass after all these advancements?
Well, this motion control system was an economy system. There's only a single translation axis. And that means that I can't easily adjust the height of anything.
Sure.
This mover is designed where just by loosening some of these screws, I can raise it up and down.
Right.
So that's really about the limit of my ability to be above or below the model is this height adjustment. And in principle, a single translation axis lets me get any distance from the model, right? Having a pan tilt on the camera lets me put it anywhere in frame that I want.
Right.
And then a 3-axis rotator on the model lets me get it any orientation I want, right? So in principle, you can kind of put the ship anywhere you want to in frame. And that was kind of the thought process behind, right? Just one section of track with a pan tilt head on it and this 3-axis rotator. In practice, I mean, this works. Yeah. It does work.
Yeah.
And I've shot things for 4 shows now with it. And the shots look good and I'm happy with them. But I would love to have a more conventional crane arm that can swing back and forth, go up and down.
Right.
Because then little adjustments that I'm making, like, when I first set up a shot and shoot a move test and see how well it lines up to the animation file that I've got, I'll see, oh, all right, model needs to be about 1.5 inches higher than this. I'd love to be able to just do that by going to the boom and lowering the camera by that amount or sliding over a little bit. Now what we have to do is if I see that, we need to be up 1.5 inches, I've got to loosen these screws, and this whole thing is pretty heavy, and we've got to, wrench it around. And that whole part is a bit awkward.
Sure. I'm curious about the first motion control shot you finished for Mandalorian. There must have been a screening, and I know how much Jon Favreau loves practical effects. How was that, that moment?
Well, we were all working on a timeline to try and get the motion control system done for a particular shoot date.
Right.
And we picked a date in May, I believe, beginning of May, that we were going to start shooting. Yeah. And then we got a call, hey, is there any way we could get a couple of miniature elements shot to show at Celebration, which I think was 6 weeks earlier than we were going to have the system together. So it became this mad scramble of, all right, what part of the model are we going to see so that John can work on? Yeah. All right, finish it off so at least we can do a shot from the front and one from the back. So don't worry about the side. Don't worry about...
Just
what's the minimum deliverable. And then I was doing the same thing with, all right, I started building the mechanics of this first, and then the next step was starting to build the electronics. And I was partway through building the electronics, and I hadn't really written a lot of the software to run on it yet. So I ended up calling my friend Joe Lewis, General Lift down in LA, and we rented one of the, he's got a bunch of motion control equipment. I rented a Cooper system from him. These are the same systems that we used to use at ILM back in the day. And I brought that up and plugged it in, and we shot with temporary hardware with the rented Cooper system and did these 2 quickie shots for Celebration. And during the Mandalorian panel, John showed this reel of us shooting these elements of the miniature, and got a very positive reaction.
Oh man, I mean, what's hilarious to me is that building the equipment and mad scramble to get just what you needed for sound is a hilarious mirror back to Dykstra and the original Star Wars, right?
That's a good point. A lot of these projects are these crazy scrambles to try and get something complete before this looming deadline, and lots of discussion about, all right, what is the minimum deliverable we need to be able to get this working?
So, are you working on a raising and lowering crane design for this camera head now?
Yeah, I've been toying with ideas for new hardware. Right now, as you can see, this is just pan tilt. And it would be somewhat more flexible if I also had a roll on it. And I've run into some problems with just the width of the whole thing, limiting some of the shot design. I can this is all flexible enough, I can turn the camera around and make the short side of it.
On the other side, sure.
So I can get that close to a model, but the original Dykstraflex head was this thing that we called the Trojan head. It was like a Trojan helmet. where the tilt rotator was a track that the camera went on, and then there was a roll mechanism to spin the camera, and then it was all suspended from a pan mechanism. And I really like that design. It's very clever. It's the camera then becomes very narrow. It's the rest of the hardware doesn't stick out beyond the camera body. So I've been spending a little time designing a minimalist Trojan head that just has to be big enough to hold a digital still camera. And the whole thing would be, you know, about like that big.
The size of a basketball or a small.
Yeah, so I'm kind of feeling like I want to build one of those next.
Yeah. You were talking off camera about the focus knob, and that I didn't know this fact. Tell me about how the focus is eventually going to work on this.
Okay, so I'm using old glass. These are old Nikkor primes from the 70s.
On a Canon body.
Yes, and there's two reasons for that. One is that the Canon cameras, as a favor to photographers all over the world, what they do is when you're looking through the viewfinder, the aperture is wide open.
Right.
And if you're going to shoot at a closed down stop, it doesn't do that till you push the button.
Right.
And when you push the button, it closes down, takes the picture, and then opens the aperture back up. The problem is that mechanism doesn't repeat perfectly. And if you're shooting thousands of frames at a closed down stop, you'll get a little bit of flicker.
Oh, wow. Because the aperture will close a little bit more or less each time.
It's just not exactly repeatable. You might have a tenth of a stop difference, and you can see that flicker in there. So one of the ways to get around that is if you just use old glass that has a manual aperture on it, where you just set the aperture and that's it. Then you don't have that issue.
Wow.
But the other reason I did that is it's another retro nostalgia thing. All the original motion control systems at ILM, from the Dykstraflex, the Vista Cruiser, and then the other cameras that I shot on, we used these same Nikkor lenses. And on Mando Season 1, when we were putting this together, Dennis Muren still has some of those lenses. Amazing. So I borrowed some of his lenses, and we shot with some of the same glass that was used on Empire and Return of the Jedi. And so there was kind of a fun retro appeal to, no, I'm using these same lenses that we shot with.
That's like right out of Stanley Kubrick's camera display, right? He's saving the old lenses. So right now, I've got an adapter here that adapts the Nikon mount to the Canon. Right. And this is a camera that has a mirror in it. And the newer cameras are mirrorless, and they have a shorter back focus distance. And what that means is that the sensor is further forward on the camera. Okay. And so if you want to use old glass like this on one of the newer cameras, mirrorless cameras, you have to space the lens out further from the body. Okay. And that space is about an inch. And that inch of additional space opens up this wonderful new possibility. So that's an inch between the back of the back lens element and the plane that is the sensor?
Yes.
Okay.
So because I've got that extra space, instead of focusing by having a gear on the focusing ring and a motor turning it, what I can do is build this essentially the same way that the Dykstraflex and the Vista Cruiser were built, where the lens was mounted to a fixed plate and the camera body to focus was moved backwards from that. So I'm going to put the lens on a fixed mount, and then the camera is going to be mounted on a linear actuator to move back, and with a bellows between them. And that inch of space that the longer or the shorter back focus distance gives me is enough room to fit all that mech.
Right. And so it didn't occur to me until you said this, that the focus knob, all it's doing is just moving the elements closer or farther away from the sensor.
And in fact, this is not technically correct for shooting miniatures because the camera body is stationary, and when the lens ring turns, all the lens elements are being moved forward and backward. So you're actually moving closer to the model by that distance. So it's better if the lens is stationary and the camera moves back.
I had no idea that the lens was stationary in the old rays.
That's why they did that, so that when you were really close and you were racking focus, you weren't adding that to the move.
Amazing. So you're going to build that functionality into the...
That's the thought, yeah.
Amazing. You know, when you need some specific parts, you can call me. I can make stuff to
All right.
drawings, and I can probably get it to your spec.
Absolutely.
John, this is so thrilling. I mean, I've been following, we've been talking about this for years, watching you go and do this, but like getting to talk about it here and hearing about the next iterations, I'm really excited.
Yeah, this is great fun.
Dude. And it's like, it's that return to old school and still doing like great narrative.
You know, part of why I got into visual effects in the first place was this this wonderful mix of technology and art, and doing these elements is kind of a deep dive into the tech, but ultimately in service of we're just trying to make some nice looking pictures.
Well, you're succeeding, man. Thank you so much for talking about it.
Thank you.
I really appreciate it.
All right.